Hello, everyone. It seems that our speaker has joined. Can you hear me? Perfect. Rahul, can you hear me? Yes, seems to be getting better now. Can you say something?
Just give me a minute.
Yes, we can hear you. Perfect. Wonderful. Then let's try if the sharing works.
Yes, I think I am audible now properly.
Oh, this is much better. Hello.
Thank you. So, thank you so much, first of all, for this opportunity. I would like to extend the gratitude to all of you, including the Professor Carl and Thomas, for helping me a lot in this process. So now, can I start?
So let's just start testing the sharing if that works, and then I'll give you a more formal introduction then.
Sorry.
Let's just start first with to test whether the sharing works. Super. This seems to be working. And I also want to ask you, so this meeting is recorded. Are you okay with that? And we'll
Yeah,
also put the recording to the YouTube. And after the meeting, I will share the link with you.
sure. I am totally fine with this.
Wonderful. And just to remind everyone of the structure of this meeting, so we'll have 40 minutes of the presentation, followed by 30 minutes of Q&A. So I encourage everyone to prepare questions. And then finally, we'll have 30 minutes of comments and discussion by Carl. So Rahul, if you're ready, the floor is yours.
Okay. Thank you so much. So, this all started with the quote I read in a book. It said that there was a quote from British scientist Alan Turing that the quote says, "What we want a machine that can learn from its own experience." So for the last 2 years, I have been studying like on the LLMs because they were extremely famous 2 years back. Means they are still mostly famous, commoditized, and commercially available. But when I started doing my research on LLMs, like would they be making it possible that an agent or machine that can learn from its own experience? So LLM seems to be failing at most of the points. So this is how it all got started, like how we can go ahead with this. So by chance or by accident, I got introduced to the term active inference, and then for past few months I have done my research on that and try to come up with something here. So let's begin. So here I am going to produce the empirical results and like how we are using LLMs here also, like we are not totally disregarding them and for what purpose we are using them. So this is a quote which inspired me to like start this, like a machine or an agent that can learn from its own experience. Then we decided to have some context, like what we will be having. So these are the few points. So the goal remains the same throughout the journey, like a machine or agent that can learn from its own experience. Then there was a paper last year from David Silver and Richard Sutton about era of experience. As we are reaching to the limitations where we can provide high quality data to the LLMs for learning. So they said in the paper like we need a new stream of data that agent can generate by its own by interacting with the environment. So the framing was like matching, again that it can learn from its own experience and even generating the data. Then there is one more paper which came I think 2 or 3 months later from the professor Bo Wen about the missing reward using active inference with using like LLMs as the generative world model to provide the priors. So this is the mostly the implementation of how Dr. Bowen described about like how he proposed the architecture, and it was never implemented. So I thought it would be good like if I can try and implement and achieve the goal here. So this is all the empirical results. Like we have built it, run it, and most importantly, we have created a pre-registered falsification criteria, like what we want, and we don't have to fine tune it to achieve a victory over the points. So how this works? So the method we use here is the falsification, not the demonstration. So each capability that we will be providing here is like compared with the pre-registration criteria that would falsify it. And all the criteria are frozen before a single line of code runs. And so we don't convert by our willing to a pass. Then we have the evaluation control throughout, like we use learning on versus learning off with mechanism versus without mechanism. Like we see how these results are working. Then we are reporting all the failures here also. So each point failure gave us the next experiment. So total for the past few months, we have run like 30 experiments approximately. 40% is the success rate and 60% we have failed, and these are the major blocks that we are facing and which is hindering the process also for our goal. So next thing we have here is so these are the things that we use like for like we decompose like how will we make it possible like learning from experience into 7 testable boundaries. Like first is build a world model from the experience, so we have achieved this. Learning online while acting, this also got achieved. Now the next is the wall that we have hit multiple times, and all the other things depends totally upon that. So in the known unsupervised and like when we provide its unsupervised environment when there is no labeling, then the agent is not able to understand that the world has changed, and it is not able to function differently. So this is the wall we have been hitting. We try to find a patch up work here, if by hint also we provide it some indication that the environment has changed, then it works, but still naturally it is not giving us the results. Next criteria is like accumulating without forgetting, like when the experiments are running for longer period of time. So the skills which were learned in the previous experiment should be uh, forwarded carrying to the topmost experience. So this is also cross, but it again depends upon the B3 where we have to give again the label. Without labeling, it is still not working. The fifth is bringing the strong priors. For this, we are using LLMs, which provides us the which acts as the generative world model. So we have used it here, and which one we have used specifically, we will be mentioning it also. Sixth and sevens have not been used now. Like none of these has been tested on a real world object like robot or robotic hand or anything. And last end goal is like it becomes indistinguishable like in an open interaction, which is still not being done. So this is the 7 frameworks that we have used, and for the same thing we have decided uh, because we are taking LLMs as the prior generator, so many a times LLMs can fake results also. So we use 7 falsification methods for each and everything, and we have pre-registered them, and then we are getting the results. So these things are there are 7 things that learning from experience terminology could be hollow, means it could mean nothing when we really implement this. So what we have is here like active inference is the control loop, LLM is the world model, expected free energy, action selection process, and online belief update. Like this is the whole thing. So these are the 7 things, like calling 7 deaths here, because if we hit by any, then the whole process is dying. So the first one is like fixed ontology, like discovering its own action and adding an unseen outcome. So the verdict here is like crossed. The second thing is like hidden human. Here we have taken here 1178 prior steps that overrides. Zero is total, there are zero ablation. So it is also crossed. Next is grounding. So they are like comparing like with learning and without learning. So with learning, there are 4 unsafe failures, but without learning, there are 56. So 14 times higher. Then fifth one is the calibration, like predicting probes versus the actual gap. It is 0.001%. It is also crossed. However, we have tried this on a very small toy environment. Next is the like metric gaming, like it's like beating its non-learning twin on joint metric. So we created 2 twins. One is like the learning twin and one is non-learning twins, and we match the result at the end, like how both the twins are working. D7 like is the most important results we have achieved, like how it becomes incapable when it starts doing something unknown, to capable when it has taken so many steps. So it reaches from 0% to 93% via self-discovered actions. But still, it remains the very simple and small environment. And the next we have is like the accumulation. Here, 7 out of 8 seeds that we provided, only 5 times readaptation was given. So it's a hit. The wall we are hitting it again. We need a label here for when the regime is changing. So this is a work where we are hitting the wall, and all the other things have been done on the very little and toy environments, we can say. Next, the hardest test we can say here was like becoming from being incapable to being capable through the self discovery. So what we did, the setup was like this: agent seeded with only one action that always fails. So over time, it has to discover the things that it stops failing. So it must discover a viable action from its own experience to solve this situation. So when we had the learning on mode, it went from 0% to 93%, solving its own rate. It is grows its own action rate. And ablation here, like when we had the different twin, it was 0% forever. So it was structurally incapable of doing anything. So discovery here is required, not only for efficiency. So this is the main thing, like for making learning from experience possible. Next, the hard problem that makes it very, you can say, little progress here is the wall that we described from the B3. Like when noticing the world in unsupervised learning manner, the agent is not able to identify this domain. So across situation, the thesis was across situation, the agent must notice without any labeling or without any hinting from our side that the rule or the world has changed. And without it, like every regime overrides the last. So it is like catastrophic forgetting and as we going ahead. So previous things are becoming completely useless and there is no accumulation. So, like as Alan Turing has the example of a child machine, like we instead of directly having a grown-up adult mind, we have a child mind, which out of curiosity, out of reward system, natural reward system, it grows up and becomes an adult grown-up mind. So here also we thought it to be working, but as of now it is not working. the simple human child can do it if it effortlessly, but here agents are not able to do. And we tried in a very simple three sets toy environment, five mechanistically, and which were different detectors were tried, and all five failed. So we will be telling here like what were those. Each one had a very different reason, and each one is worth looking at. Okay, so these were the five detectors, all where the agent fails in all the detections. So first was the error magnitude. So when environment change, it starts giving us the higher error, and it had the nothing learned in that particular environment. It was indistinguishable for the agent. So agent was not able to identify that things have changed in its environment. Then there was a capacity limit. So when we tried to retain the knowledge, it hit at the 128 only. When we tried to increase the capacity, it started reversing. So it's a maximum optimum we have reached. So it is also a failure for us. Next is the error dynamics and also slow. So settling was a shifting share a time scale at toy scale only. So even at toy scale, it is providing like the huge problem. So once the environment scales, it is going to be a big problem in solving. Next detector was intermodal divergence. Like the signal has a structure, but there is no dynamic range. So we could achieve only 0.03% maximum, which is almost negligible. We can like consider it as a zero itself. Then there's a forced diversity, like detector. So pushing models apart makes them hedge the same corner. So it means like when we are forcing the diversity, it's still the we are not getting anything in terms of results. So these are the five failures, the wall that we have been hitting, even at the toy scale only, that we have not been able to achieve or solve using anything. So this was the inflation point. So we thought that what if we, instead of scaling the model, we scale the world, we change the system, because a three-state world it's has a very less degree of freedom to generate a signal or for an agent to identify a signal of that level. So we thought to change the environment, make the environment richer. So this was the environment we took. We took a simple kitchen theme here: four objects, six actions, and two hidden rule sets. So these two hidden rule sets were not given to the agent. It had to identify itself over a period of time. So the objects were microwave, blender, oven, and mixer, and there were six actions per episode. So use microwave, use blender, use oven, use mixer, reset microwave, reset oven. So there were two hidden rules, like when you use microwave, what happens? When you use oven, what happens for everything? So like a rule set like use microwave, it heats and it heats. Use blender, it steams and then it beeps. Use oven, it glows and it continues to glow. Use mixture, it weaves and then it cools down. Reset microwave, it remains silent. Reset ovens, it cools down and it spins again. So this is how we try to do it. Then here comes LLM in the picture. Like here we use it for props. So in a simple interactive world, you have observed the rule. Like when you use a microwave, it heats. When you use a blender, it steers. When you use oven, it glows. When you use mixture, it weaves. And when you reset the microwave, it's silent. It remains silent. So what is the effect of resetting the oven? So here the LLM provides only effect phrase, no exact code. So the LLM responds like what happens when you reset the oven. So it gives the single word cools. So here we start then the decoding process, like do sample equals to false, so it's greedy. Maximum new tokens is the 16 is the limit. Post process strip or lowercase. Compare first token match. So we always compare the first token match. So how does it look like by episode, by like step by step? So when we have the step zero, so there are three props sampled: microwave, blender, mixer. LLM predicts are unknown here. Actions are normally heats, surveys. So what we achieved? Nothing. So detector is just warming up. Even on third step, there is nothing. Detector is quiet. Till 11th also quiet. At the 12th step, the detector starts firing. but still it is 2 out of 3 are false, only one is wrong. So when LLM predicts that blender should be stirring, mixture should be whirring, and microwave should hit, so it matches only last one microwave. So two are fails out of 3. And in the next steps, one is fail out of 3. So here it becomes 2 by third by the step 13. So this is the recipe that we have used here, means to simplify the whole process. Like this was suggested by the Thomas Parr. So again, gratitude to him for this. So here we use the regime detection as the recipe. So the full loop in one view. So the whole loop goes by this. We take sample 3 actions uniformly at random from the 6 variable. For each action, if the belief is known, take action, observe and store. If the belief is unknown, query LLM with the belief table prompt. Compare LLM prediction to the actual environment response. Fail, pass, yes, no. On mismatch, count one error and override the stale belief system. Then compute the failures equals to errors divided by predictions at this particular step. Then the sixth step becomes like this fire detection if and only if the fraction of failures t is equals to or greater than 0.66, and if fraction of failure t is higher than ruling baseline t4 to t1 plus 0.30, which we achieved from the last, like we achieved at step 12, 2 failure first, then 1 failure. So the methodology that we have used here, like what is stripped and why. So there are active inference element here like A, B, C, D here. So A, we use the likelihood here. So status is an experiment is sampled. This is completely sampled implicitly by the LLMs. So we have used sampling here, sampling method. And where it is used, so we use here in the A likelihood. Then for the B element, it is not modeled. Detector aims to detect it. So in the accumulation experiment, where regime key was memory, where it failed mostly, so it could not be done. See, for the C preferences, it has not been used, only purely epistemic experiment, self-discovery, Goldilocks adaptations. Then for the D initial state priors, belief starts unknown for every action, and where it is used like for the future work informed prior for from LLMs. So these two things are working together here. Then for the expected free energy action selection, this has not been used. Uniform random props has been used. So when we have companion experiment, when we took with this and without this is the comparison where in self-discovery, expected free energy scores candidate actions were taken, like which has the lowest form of expected free energy, those actions were taken. And the Bayesian belief update, it was direct override on mismatch. And again, it remains like the future work for full posterior at scale. On because on very small environments we have targeted. And in the state changing environment, it still remains the stateless. Regime change happens by the step index. So again, we need the real grounding here. Track B, we are like working on object centric active inference here to bring again here. So this is still not been done. So talking about the breakthrough that we were talking 0 to 93% here, like the subset that crosses here. So we have used this. We did not change the detectors. The detectors which were failing in the same three-state toy environments, we use the same detectors in the text-based richer environment. So those detectors started working when they got the richer environments. From this is where the line came that don't scale the model, scale the environment. So what was the richer environment was like a semantic text world where rule change makes many related predictions fail together. A cluster signature, a single scalar cannot see. So we also use here handwritten semantic world where 85% it was true switch deduction. There was zero false alarm. And During the self-generated world also, where world model authors each one, there was still zero false alarms, and it was completely generator independent. But it was lesser than hand-written semantic world. So the bottleneck was never the algorithm of or the compute, it was the environmental richness. In the toy state, it was not able to identify or detect the signal, but when we provided hand-written semantic world or self-generated world, it was able to achieve more than 82 or 85%. Okay, next. So the three like empirical updates we have here is like earlier we used Quen model, Phi model, Mistral, like all the freely available model that are available on Hugging Face with their weights, very small versions of model. At the last moment also we use the Gemma model of from Google also. So the result was 72.5% detection was there, but false alarm was all four false alarms were there. So we wanted at least to have as minimum three alarms, so it failed. So what it tells us about this, that the confident prior leakage failure mode previously seen on the Mistral model is replicated here on the second model also, which is from different vendor. One is from Mistral and one is from the Google. The mechanism is real, not one off. Second thing, the agent must integrate novel vocabulary, new actions, new effect word mid episode. But it was still done on a very limited vocabularies. So we use two models here, like the Phi model from Microsoft and the freely available version and the Quen 2.5 model. So the detection rate was high and there was zero failure and it was 100% novel vocabulary integration. So it brings us where like this substrate is integrating the labels that it has never seen. This is a good point here. And under redeem change also it do very clearly. So the model behavior is identical between the two vendors. Like from the Quen and the Phi, it achieved exact same percentage. So the third thing where it failed on all the criteria, which was an important function, like predicting an unseen combination of a known verb with a known color that agent has never observed in terms of pair. So even the Phi model also and the Quen model also failed. There was only 2.5% match. So it failed on all the criteria. So this is again the genuine frontier wall, that this substrate does not form compositional component from in context experience also. So here the pre-registration held across positive, partial, negative, all are included here. The discipline that we use is the methodology, honest result every direction, like mostly because of the first one and the third one, it goes to a very partial gain. Okay, next we have is the capability ladder, like where we are, where is the wall, what we have done. So each ladder was pre-registered with the empirical test. Position on the result is the like the ladder is the result. So capability, the test first was the unsupervised regime detection on hand curated semantic world. It was cross 77.5%. Then SAM detection on the 50 themes the experiment did not author. So our passing criteria was 70%, so it achieved only 67.5. So there it you can we can call it either pass, fail, or partial pass. Next was integrating the novel vocabulary that was never shown before. So it was 95% passing, 100% integration of vocabularies, and there was zero false alarm. Last, which is the very big wall, compositional concept formation. Like it was not able to bring the original concept, which it has never seen before, like predicting them. So it was only 0.25%, so almost we can consider it's negligible. So these substrate handles regime detection, novel vocabulary, but it is not able to handle compositional concept formation. So this is where the wall is. Okay, so these were the models that were used for deployability. We use Claude Opus also, but it was an internal model. There was no API here. Uh, and detection rate was 82 to 85%, and we took only as a reference. Means really we tested it only internally. When we had the real test run, the Claude Opus or any model were not used. So the Quen 2.5 model detection is 77.5%, and the Phi 3.5 also has the same detection percent, zero false rate. They are completely passing. So means when we have a small model that understands the world, like that they have the common sense of the world, which was also described in the Bowen's paper also, like why we are taking them as the generative world model. So they have, like, they are giving us results here. But for the same thing, Mistral's model could not pass. Like it achieved 67.5, and more than that, it was providing false alarms also. So it could not be done. So it was providing the leakage of information. So here the reason detection across is the free local runnable small models. It was confirmed by different two vendors, and the size, but actually here the size is very small. We have taken only and close to two here. So we found on a very small batch we have tested this. And next, though no frontier inference was used, no API was used, and we use only the Google Colab provided Tesla 4 GPUs as long as it was available for us. So here, when we use the baseline, why we use the reference here? Because instead of directly using the APIs, what we did, we created an internal API system where we created a wall. Whenever the system asks for the LLM probes, the internal LLM system considered this as a API call and answers this. So it was much more slower process. That's why we kept it out of this just as a reference. Next, the reason why Mistral fails and Gemma also fails is and like instead of fine tuning them, also we also excluded them. Like because their false alarms were three, like the theme stratified. They were clean on how low prior content like telescope, kitchen, but they were very leaky on strong prior content walls versus pumps when we tested on different environments. So here, when we use the KSA mechanism, the leak is means the confidence level was 82%, and despite having the 82% confidence, it failed on its all the prediction. And when we use the twin prediction consistently with from experiment of three, so only there were only 14% reduction. We hoped for 50% is needed. So that's why it did not work in Mistral also. And because the leak is confident and not conflicted, a sampling size filter cannot catch it. That's why we opted out of fine tuning it. So remedy is a model choice, not like prompt engineering here. So we did not use the 7 billion class limit model. Maybe their current versions which are available with the APIs might do better work, but we are not aware about that. Next, so there was one methodology error that we happened to catch it by chance. It was when we were shifting from like from S4 to S5. So in experiment 4, we used four probes. So Quan and Phi returned near identical 20 to 25% and looked like a model failure. So what the diagnosis we did, three changed rules and four probes per step. Fire probability dropped from 0.5 to 0.2. The detector mathematically could barely fire. It was not, there was no firing. So it was a configuration artifact, not a model result. So again, pre-freezing registration gap here. When we check the fire is possible, but fire probability at that configuration was not possible. So again, in the next experiment, we reverted to the proven configuration. Both model again recovered to 77.5% with zero false alarms. So this was again a methodology error from the side. And the smoking gun here was that both model hit and missed the same episode. So this was also a clear result. Like it was not a coincidence that we tested it both the times, that they were hitting on the same and they were missing on the same thing. So it is a case of sampling process, like not the quality. So here two mechanisms proven, but they are load bearing and they are not decorative enough. So what we did when we had a self direction, irreversible dead end tree, exploration probably insufficient. So in directed it was 200 and in undirected it was 0. So it's a major roadblock. Again, another thing was adaptation. Like we use a Goldilocks task here, target reachable only via the change dynamics. So with adaptation, 20 were hit, and without it, 0 were hit. So because of the self-discovery, this was very important. So without mechanism, the self-discovery was complete failure here. So if we want to talk about like how this was we are positioning, but one caveat here is that we are using a single laptop and the resources of GPU available only on as long as for sometimes 12 hours continuously. So on a very small toy scale environments, we have tested the things. So we are using LLM priors here, we are using active inference here, we are using the cross regime detection also here. So these are only empirical result. Once we taste in the real environment, result might differ. So the framing is like overall, if we want to understand that the language model is not the agent here, the LLM is not the agent. It is a world model component. It only passes the priors. Uh, and the second thing is the active inference machinery, where the cluster detectors we have, expected free energy we use, and belief updating. This is the agency. So this is consistent with the view that LM alone lacks agency. They don't have the agency, which was also described in the paper of Bowen. So the honest scopes the limitations that what is proven, what is bounded on conditions, and what is completely unbuilt here. So it learns from experience. 7 falsification tests have been done. Regime detection cross into environments, and it is generator independent. Cheap small model as a class, n equals to 2, so it's a very small scale has been used. Zero false alarm using the phi model and Quen model. Self-direction and adaptations are load-bearing as of now. What is open-ended or what is bounded as of now, that which the class itself. So it's a n equals to 2, not a field wide like Gemma. We have not tested completely as of now. Detection ceiling right now is 77.5%, and it is also limit environmental based. So we don't know now. Once we scale it, are there chances that it will improve from 77.5 above, or it will bring everything down? Again, the forgetting test is conditional on the regime change. So there, the B3 from all the B1 to B7 is the most important. That is the wall. B4 depends on that, and B7 depends on all B1 to B6. So if we don't have the clear answer of B3, all the things are kind of decorative. And there are mistakes like Mistral model style leak, model specific. So we have not tested in all the models available freely or with the API charges available in the world. So once we have tested them, the result might differ. So what we have not done here is we have not tested in even in any simulator. Online also, we have not tested in any kind of robotic environment. We don't know when we use the parallel reach world or when we have higher computing, will it scale like LLMs have scaled? And self-direction, like it is getting the self-direction now, but will it be having self-direction at a scale? It is also not answered now. And one more big hurdle, like open-ended concept formation, it is failed itself. We have not been able to overcome this, like using even all the things, all the components, or using all the best of all the worlds. Still, we have not been able to solve this. So the path that we seem that goes from here is like that the mechanism is proven on very small scale. So scaling is mostly in engineering or research, and it cannot be done on a single laptop itself. So we need a simulator where we can use it first there, then we use in embodied system, then we can use in robotic environments. Then we can scale it to parallel world training, self-directional scale. Then open-ended is still open, like inventing categories has never been achieved. So each of these has been gated one before, and the dependency that we talked from B1 to B7 all depends on the B3, and until and unless B3 is not resolved, all these things will continue to hit the roadblocks. So with this, like I would like to extend my deep gratitude, first of all, to the Professor Carl Finston for his encouragement and endorsement from the first day onwards, and for introducing me to this group, as well as giving me or helping me connect with me to Thomas. And and I would like to extend the heartfelt gratitude to Thomas as well. Like he helped me a lot over the call, over the emails. So for the last 2 months, this has been very much helpful, and the entire active inference community and all the papers I have read that I could read very fast in the last few months. So without all these things, I don't think all of this could be possible. So again, it in the single line, the goal remain the same. A machine or an agent, if we want to have general intelligence, super intelligence, where it can learn from its own experience instead of relying upon the human feedback or designing the human reward. So uh, when we had the paper last year of era of experience loop, so did it showed the path that this is how it could be done. But instead of using the pure reinforcement learning, where the problem of data curation is solved, but still the reward curation remains. So here the intrinsic motivation that comes from the minimizing the expected free energy. Once we have that loop and we have the learning experience, so we hope that the missing bridge between the era of experience and intrinsic motivation of minimizing the expected free energy can be bridged with the using LLMs as the world priors, because LLMs are not completely useless. Like they may not one day turn out to be AGI or SI, but still they can provide us the common sense or the common information as they have been trained on the last human text available for the 2000 or 3000 years possibly. So that is all. Like this was the theme till now, like scaling the world, not the model. And this all has been done. And before you ask questions to me, I just want to request, like, I'm not a mathematician or not a scientist, not even a researcher. Like, out of just curiosity, I have been doing this work. So I might find it very hard to answer your questions.
Wonderful. Thank you very much for your presentation. Let's give Rahul a round of applause.
Thank you so much. Thank you. I think still I have done the least work possible, because most of the things I have taken from all the people who have done their research, like mostly the Professor Carl himself, the Thomas, and thousands and hundreds of researchers throughout the years and decades. So my work is mostly just curious, like tinkering, we can say.
That is wonderful. Wonderful, really sweet. Um, just before we move to the Q&A, I just wanted to ask Rahul, how can we be useful as a theoretical neurobiology group to you? So what kind of feedback would be the most useful to you from either audience or from Carl?
Okay. So like as I told, like the goal remains the same. Like like I will tell you like how in the short, like for last 2 years, how this the journey has been. Like I started building from December 2024, and I like the personalized AI tutor, which can use LLM as the base, and on the top of it we can build the model. So we wanted it to have the two qualities, first of all, which will make it completely different from all the other AI tutors were available. First was the deep personalization. When a simple question is asked, like what is photosynthesis, by a person who belongs to a completely rural background and a person who belongs to a completely urbanized city, so the answer should be provided extremely different using their background and the chat history or the memory that the model knows. And the second was the like deep immersive experience that we can have with the videos. So once we were building, when we hit so many roadblocks, so we found that in this till December 2024 or January 2025 itself, the LLMs were not capable enough to have this. So we came to base again. Like instead of building on the top of intelligence that already exists, why not something which is missing in intelligence? Try to start working on them. Then I started working on the JPA system, like joint embedding predictive architecture, like mostly popularized by Meta AI scientist Lee Kuhn. It works very well for when we want things like videos and robotics things for the car, autonomous cars, drones most probably. But still, learning from experience, like acting in real world, it still lacks a lot of things. Then the last I came by accident or by chance on the active inference, and then I started reading and all these things. So the framework, like where we can minimize the expected free energy when we are planning about the future. And the environment I took as an example was, for example, if we send the robots on the Mars and the Moon for creating the colonies for humans. So the era of experience by Richard Silver and Sutton was like complete trial and error process. Like it runs billions of experiments and billions of trial and errors. It will work, it might work very well, but who has the capacity for billions of trial and error things? So here, if we can use like the minimization of expected free energy, we can already eliminate the things which will not provide us the desired result. Then the trial and error process could be minimized, and we might achieve faster if we want to like have us like the colony on the moon, Mars, space, and everything, where the environment is completely extremely uncertain, and we need to minimize the surprise as much as possible. So this is where like the active inference came into the picture completely. So the feedback would be like the main goal for a machine that it can learn from its own experience, like this two words, first is learning and its own experience. These two words are very fundamental. So like how it can be done, and what are the limitations that, because you are the experts here, so what are the limitations that are still not like tested, or which are still the limits, and those limits are like the engineering limits, or those are the fundamental limits that we need to find some alternatives for those. So like any feedback, any question and answering around that would be very much helpful. And once and if you are going to ask me about all the deep things of active inference like ABCD matrices, I may not be able to answer.
It's completely okay. It's quite an agenda that you have on your plate. Okay, so I think now we're ready for the Q&A. People, if you have any questions to Rahul, feel free to just join in your questions or raise your hand.
Feeling nervous.
No questions from anyone?
That's really great. Okay.
Carl has a question. Carl.
Yeah, I was rather hoping to hear Thomas talk about his experience in conversation, since my last interaction with the rule.
Sure. So part of the reason I'm not asking a question is because I've already had a chance to ask some of mine, but perhaps the most useful thing I can do at the moment is just sort of say what I've understood. And I think I've understood slightly more each time I've seen this presented or had a further email about it. So first of all, the slides are looking very polished and very professional, and you presented that very well. If I'm understanding correctly, the premise is that world models are a really important way of getting towards this problem you're interested in of machines that learn from experience and the sort of long-term ambition of thinking about how they might be used in situations where it's very difficult to gain experience, so space and other sort of frontier areas. And one of the real challenges is knowing how to specify that world model to begin with. And if I've understood correctly, the solution you've come up with is that there's a lot of statistical knowledge already embedded in large language models based upon what we've understood or what's been captured by language so far.
Right.
And so you can use the large language models or some of those statistics or find a way of probing that then allows you to use that as a way of either specifying or being a component of a generative model.
Right.
And so the idea would be that by asking a large language model a question or giving it a prompt, that is in a way a means of sampling from a kind of world model that embodies what might have been learned from prior writings and whatever the large language model has been trained on.
Yes.
And so when you're running these experiments, you're effectively giving the large language model a little bit of contextual information to begin with that gives it a sort of task set. You're
Right.
then giving it queries to see how well it performs in a particular setting, and then changing the contingencies or the rules by which you're generating the answers you give to it.
Right.
And then there are a number of benchmarks, and this is the bit that I still don't fully understand, that you're using to assess it and to score its percentage response on particular kinds of tasks. And I admit I still don't have a good grasp of exactly what those are. Now, in terms of the sort of specific things that I guess I can say here, first of all, the problem you've identified generically as it doesn't know how to deal with it when the world changes, I think makes a
Right.
lot of sense in that when you presented your slide as to what's actually involved in the particular model you're using, you are quite clear that there are no transition dynamics
Right.
baked into that model as is. So I think in terms of your query, how do you get around this problem of representing or recognizing when the world has changed? I think that
Right.
relies upon there being something in the model that deals with that notion of change. I wonder whether you could do that in a similar way to how you've approached sampling from the likelihood. If there is mileage in this approach of using queries to LLMs as samples from a generative model, could you do the same thing with transition structures and say, given this is the current set of states of the world, where do I expect to be next? I'm not sure how you use the response that you get from that or how you interpret that or convert that into a probability distribution that you can then use to apply expected free energy and all those other things. Um, I'll come back to that in a second. I was going to ask what have you done in terms of using the expected free energy and how have you been calculating that so far? Don't answer that just yet, but I'll just come back to that. The other thing I just wanted to sort of think about is um, what's there's plenty of things we could talk about probably for hours and hours here to try and unpack a lot of the details and understand some of the details and the like, but I'm not sure whether that's going to be the most useful thing for you. Um,
Right.
the question I have in my mind is sort of the first one is how do you find the right sort of support if you want to take this forward in a more serious way, or if you're thinking actually no, you just want to keep it as you described, sort of tinkering as a hobby of sort of developing this out of interest and curiosity. There's two directions you could go there. So what one is, you just say, actually, this is a hobby. I want to keep exploring this. I want to indulge my curiosity in that, which is perfectly fine. The other would be to say, actually, I need to develop this in a more sort of formal, rigorous setting, whether that's a matter of sort of looking to do PhDs or master's projects or whatever else, and getting some sort of institutional support locally, um, or sort of any other direction that you might have thought of there. So I guess my first question is, what do you want to do there? Do you want to pursue this in a sort of serious, formal setting? Or is it more that you just want feedback in terms of what you might want to think about in terms of the sort of curiosity in indulging side of things?
The direction I want to pursue is like the series, like where I can we can have this thing possible where we can make machine really learn from its experience, and we can have one day the end goal, like as you suggested, like where the robots are carrying this as their brain, and when we are having the space, the completely most surprise giving world where we need to maximize the surprises or the expected free energy. So I want to pursue in that direction.
But when you say pursue in that direction, do you mean as, sort of as you're doing at the moment, as a sort of hobby to try and work towards that? Or are you thinking actually you want to focus on this as a career,
As a career, you
venture?
can say, as a startup, we can talk about.
So, okay, so you want to sort of take it forward in that industry setting. I suppose
Yes.
the question is, then what sort of support do you need to be able to do that in that industry setting, and who you need to be recruiting, and who you would get funding from, and all that sort of thing, which I appreciate are not easy questions to answer. But
I had the very easy answer for this, for which I already asked and I already got rejected from Professor Karl himself. I would say, like, it is out of curiosity. When I was reading the all the papers of like the active inference field, I even didn't know properly about you, about Professor Karl and all this community. I just thought you are just some researchers and some scientists around the world, so I might directly ask you to be my co-founder and start the research with me. I later on, when the Professor Karl informed me about, like, he has gone into semi-retirement, and he generally engages mostly in this group, and then I asked the same question. Then if I cannot have you as my the main person with I can carry this forward, who could be? Who with whom can I take this forward in the next 1 decade or next few decades? So then the Professor Carl suggested that Thomas is the right person and the best person for this. So what I need, even before funding, I think the most important question is about the team. Like once we have the right team which is working on this, then we can think about like how we will get funding, from where we will get funding, from where we would want it to be having its main offices, like London, Europe, or from my country, India. So I think these questions for me are for funding, and the places are for the later questions. The most important questions are the team, because I feel the teams are everything. Like once you have the great teams, like great difficulties and challenges can also be overcome. But if we don't have the proper team, still we can hit roadblocks against it.
okay. Um, so so part of it then is finding the right people who you can work with.
Right,
I mean, which may be challenging to begin with. So I
right.
think, as I've mentioned before, I spend most of my time working as an NHS doctor, so my capacity
Right.
sort of work on these sorts of things is quite limited. So, I'm not the right team member for you. I'd be interested to hear whether anybody else on the chat sort of whether it jumps out to them as a really interesting direction they'd like to learn more about. But the other thing is sort of thinking about then just engaging in more groups of of people who are doing active inference related research, just so that you've got the opportunity to interact with people, particularly those at a sort of earlier career stage. And I think you've already made contact with people at the Active Inference Institute and places like that as a way of thinking about that, which I think is really good. Fine. I'll put that question to one side for the moment then, and then just a sort of question about the more technical aspects of it. I appreciate you might not be able to give a really firm answer on the technical detail, and that's fine. But just that you mentioned that there are other applications of what you've done other than the example you gave us, where you have used expected free energy. I just wondering if you could sort of give us a sort of simple example of the kind of setting where you've used that and how you went about calculating it.
So like in this experiment, like the set of experiments itself, like when we are using the LLMs as the prior common sense information giving, once the LLMs provide the answer like this set of options could be the right thing, then we start experimenting with the like minimization of expected free energy. So whichever may provide the expected free energy, we choose it from the recommendation provided from the LLM. So on the like in the environments that we have taken here, this was all done with the assistance from the agents provided from the cloud agents and the GPT agents. So most of the I think calculation has been done by them. So deep technically, I don't know how what exact calculation was done, but the architecture remains the same. Like the LLM chooses the candidates over them, then we use the active inference loop, and we use the candidates which has the highest likelihood of providing us the best answer or the decision possible. Then we start the learning process, online learning. We adapt the model, then the loop continues to grow on. Like this is the most I know.
Okay, so that's given by giving particular prompts to these systems, is it? Or what sort of prompts do you give for it to then calculate these things? I appreciate you don't know the details of calculations themselves, but what do you ask it to do in order to achieve that?
Like as we have taken the example of the the four objects like microwave oven and all this. So when the LLM already predicts, like because LLM already has, this is a very normal environment for LLMs, like when microwave will function, so what will be the process? So here, when the LLM's prompts are given, then the active inference itself takes those things. Like it has to detect the signal first of all. In the beginning of the 11 steps, like there was no signal, or we could say signal might be there, but the loop or agent could not detect. So it was detected on the 12th step, then on 13th step, and then the loop was ended. After that, it could never be achieved out of 3 out of 3 or 100%. So on 12th step, it was 33%, on 13th step, it was 66%, because only one was only achieved and only two was only achieved. So this is how it was done. Uh, I hope I might have answered.
Yes, I'm not sure I understand 100%. But I suppose that in itself that's sort of quite useful in sort of thinking how you're approaching this. And I think that's sort of practically relevant for a couple of reasons, sort of coming back to the earlier question. And it's thinking about sort of who you engage and how or what else you might need to do to do this. I suspect that you might. So I think that I'll separate out. So there are some really positive things. So I think the idea behind trying to leverage the statistical information in a large language model as a way of sampling and creating a meaningful generative world model, I think is a really interesting idea. And I don't know for certain, but there may be some mileage in doing that and making use of that information. And I think, although you had it as a negative, I think the fact that you're able to do a lot of this on a laptop is a positive thing as well, because it means that you're dealing with the sorts of things that you can implement on a device that doesn't necessarily need to be connected to a big server or a lot of compute, although I suppose part of that depends upon exactly how the large language models you're using are working as well. But I think being able to do things in a sort of low compute setting is a positive step rather than a negative one. I think you've identified some of the key problems and things that need to be solved. I think the more challenging side, or the thing I think you'll probably struggle with a little bit more, is in engaging the more academic community in some of these ideas. And the reason I say that is that I appreciate your focus is much more on the engineering side of how do I create the right prompts that create the right models that will solve particular benchmarks. Whereas I suspect a lot of people on the academic side are probably going to be more interested in the mechanisms, the details, a lot of the sort of maths that's underneath this. And so you might struggle with some of that community to sort of to reach them through that. And the reason I'm saying that is just thinking practically what you do next. And one option would be to sort of take a more formal route to skill yourself in some of these things from that academic setting. And that might be looking to do master's or PhD related research somewhere where there's good engineering expertise and people who can sort of help you develop on that side to then engage that community. The other would be to say that actually, rather than focus on that engineering side of things yourself, if you were able to obtain funding for some of these ideas and attract the right sort of engineers and people who have those quantitative skill sets, then that might be another way of going. But I'm just putting that there as a sort of those might be the two directions you might want to think about. Either, as I say, sort of skilling yourself in the academic disciplines around this, and then sort of trying to engage people on the academic side, or saying actually that's not the bit that you're going to contribute, that you're going to sort of gain the sort of broad vision and ideas, but if you can find other people who you might be able to employ to work on those sorts of projects, those would probably not be academics, I would have thought, but might be other people with those skill sets in software engineering and engineering backgrounds. Does that make sense?
Right, like the path, like I am like myself, like I am a computer science engineer, so like that's why I understand more in terms of engineering and solving this.
Yeah,
Like in
which is entirely
academics,
reasonable.
yes, thank you. So like as far as like the academics are concerned, like I read the book also which you like Professor Carl like authored, like on Active Inference. I tried to understand as much as possible about like taking about the high road and the low road, everything. Only the part is that I think like the calculating the first variation of free and energy, then expected free energy, then using mathematically with this LLMs and the loops, and this is where I feel like somebody who is very good in like in academics might do a great job there. Like you can call it like complementary skills of a team, like where I can do the most of the engineering works and the person from academics can do mostly like theoretical mathematical formation, like when we are hitting a roadblock or something. So I think this could be might a better direction that I think could be right.
Yes, I hear what you're saying, and you know maybe you're right on that, but my suspicion is that the people who are going to focus on the sort of mathematical detail and the research on that side will probably continue to do so, and it might be difficult to persuade them that doing it based upon the particular formulation you have in mind is going to be the most attractive use of their time, if you see what I mean. I may be wrong, and you may find that there are people who actually want to go straight for that, and I'd be really interested to hear if anybody else in the conversation wants to jump in on any of that. There may be people who sort of see
I
this and really speaks to them.
I think if I see the trajectory of myself, like learning from my own experience and practice. So only just few like some time ago, I didn't know much about all of these things. Like all these things were like you can say completely Greek to me. They were going above my head when I read everything. But in few or very short span of time, I find myself that I can understand at least superficially or some things. So if I give more time over it, like even mathematically also, like I started even making my own notes also, like how all of these things can work and how can we make all of this happening. Like taking inspiration from your book, I myself like made a lot of I like I would like to show here also like these are my handwritten notes. Like when I was reading the book, so I wrote very simply like what I basically understood also. I think once I give little bit more time, maybe some more weeks with singular focus on the mathematical side of that, I think I might be able to understand at least what is existing as of now.
Yes,
And
it's clearly very impressive that you've learned what you have in sort of your own time without that sort of formal support. And you know, maybe the way forward then is to sort of get more involved in that community, sort of particularly some of the discussion groups and things that are run with the Active Inference Institute.
right,
Just get used to how people speak about these things and how they communicate them and what engages people, and maybe that's the way of finding the people who this speaks to in a more direct way.
right.
I'm going to stop now because I think I've run out of additional things to say. But thank you for the talk, and I'll be
Pleasure
interested
is
to
all
hear what
mine.
others say.
Thank you to all of
Thank you, Thomas. Any more questions from the audience? Because if not, I think we can move to Carl's part.
Is it my turn now?
It is, yes.
Good. Thank you. Well, I mean, Thomas has been me today, hasn't he? He's left me with 13 minutes. That's good. So yeah, really engaging talk. And I'm glad I've had the opportunity for you to present your work and ideas and aspirations. It's unusual from my perspective, but almost refreshingly unusual. On the other hand, I have to concur with Thomas that it's going to be a journey to really pursue this in a way that sort of supports you in terms of giving you a salary or giving you an academic affiliation. And on that note, it sounds to me as if your best bet, I think, is well, it depends how secure your current job is, but if you're looking for ultimately working in industry via a startup, I think the best thing is to probably get engaged and employed by a startup who have the same ambitions and aspirations that you share. The slight problem with that is that most of them are in stealth mode. So you don't know who to contact. So it's a bit of a catch-22. You want to be on the inside, but no one will tell you where they are on the inside. And even I don't know. Even some of my colleagues and co-chairs are currently in stealth mode, and I don't know exactly what they're doing. But I do know there is a community out there that of your age that shares the same aspirations and curiosity and excitement about leveraging all the wonderful engineering that we've seen or witnessed over the past decade or so that has culminated in large language models with the principled approach of active inference. And I get the sense that's what that's exactly what you would like to do. There is a community out there that has the same commitments. You've just got to find it and find a community that will pay you to be part of that community. I don't know how to do that. Thomas doesn't know how to do that. But if you can do that, you should certainly do that. One practical way of getting into this field, certainly the Active Inference Institute, I think, is the first place to start. Just get used, as Thomas says, to the way that community thinks and talks about things and their hopes and aspirations for the common good. And they're certainly not allergic to large language models. Daniel, the co-director and founder of the Active Inference Institute, his personal work is all about using large language models to understand active inference. So it's all the other way around, really. So, however, I think what would also help, if you go through the list of the attendees and presenters at this year's International Workshop on Active Inference, and then go carefully through and see who are they working for, what are they doing, and try and guess whether they are involved with a startup at the moment, and write to them personally and say, look, are there any opportunities? I don't think you're in a position to start your own startup at the moment. I think you're going to have to learn how to do it. It's an incredibly difficult venture, and very much like becoming a computer scientist or doing a degree, or as in many things in life, it's probably best to learn how to do it and see how to do it before you start trying to do it yourself. So I try and get into bed with a current startup who has this bilateral commitment to active inference, a first principles approach to learning from experience, but leveraging and using all your computer science expertise and all the engineering prowess that has been installed in these foundation models and smaller models to which you have access. Along those lines, it does. I think there are a couple of things that you might think about pursuing. The first thing that comes to mind is your conclusion about scaling. And the resources that might be needed to take the kind of thing that you have been doing to the next level. I would push back against that, and I'd actually put it as part of your, part of the motivation for the kind of work that you have been doing, simply because it's likely that the application of the technology to which you aspire will be on the edge. It's not going to be, so let's take, for example, into the unknown. You're now working for a startup that's trying to engineer drones to deliver emergency relief supplies to miners in terrains that are unknown and indeed unknowable because there's just been a collapse of a mine. Okay? Now, the kind of learning from experience and artificial intelligence required there is going to be on the edge on the drone, and possibly GPS denied because you're underground. So you can't use GPUs, you can't use large language models, you can't use the foundation models. You have to use something that is fast, frugal, first principle, maximally efficient, conforming to the principles of least action. It has to be active inference. So the question now is not how do you install active inference into large language models? The question is, what can you leverage from large language models to make active inference even more efficient? On that view, I think you would. I think that's basically where the conclusion you've arrived at, and you've been demonstrating in part with your sort of text-based kind of learning from experience. It might be interesting for you to read around deep active inference, which is leveraging the notion of amortization. And I did notice that you were talking about sort of effectively amortizing or using large language models to amortize the likelihood mapping. Well, given this, then what would I see or predict or see in terms of content? And I think Thomas was suggesting that there may be also the opportunity to amortize the dynamics in terms of if I switch the cooker on, will it stir or will it get hotter? So putting action into the game in terms of consequences that unfold in time, in the sense of the dynamics encoded in the B tensors and partially observable Markov decision processes. So that's where I would recommend you go. And exactly as Thomas spotted, the fact that you're doing this on a laptop is actually a vitally important constraint, because as soon as you can't do it on a laptop, it's no longer interesting. So your challenge is to do your scaling on a laptop, and I think there are ways of pursuing that. And when I finish, I'll just quickly flip through 3 papers that might be useful for background reading, in terms of, if you haven't read them already, how we might approach that. One way of addressing the scaling problem is not to try and scale up, but to try and identify the scale-free principles that you could apply. So what we're talking about now is having 2 laptops, each running a small foundation model, learning from experience, but composed hierarchically, so that you're now effectively using one to contextualize the other. So a simple idea here would be to say, if there's any sort of attention heads required in terms of generating novel prompts for which you can then evaluate the expected free energy, or in the sense that I didn't understand either, but you tried to explain to Thomas. Now the second large language model is now trying to predict the contextual succession of attention heads. So you now tokenize the attention head, and that will change much more slowly than the content that is being generated by the first laptop. But now you've got a second laptop that now can reach much further into the future, because it's now using it's now predicting the next attention head. So that would be one example of scaling via recursive application in a scale-free context of the separation of timescales, just using laptops. So that will be one way to actually just indulge in this at the weekends, indulging your curiosity, or something that you could develop in partnership with colleagues in a startup. The other thing that comes to mind, and largely as a result of your presentation, but also in your conversation with Thomas, is this notion of using foundation models that have installed all this cause-effect structure in narrative text from millennia in what they know. And I'm just wondering whether another application or a way of showcasing what you want to showcase, which is learning by experience, is to use the foundation model as the world, and to show that a laptop-sized active inference agent powered by a small large language model can now learn from the large language model. So we're not talking about learning from experience in an embodied world, but we're trying to solve the problem now. I've got a small untuned, really small, very ignorant large language model, and I now want to learn from a big one. So now the foundation model becomes the teacher, and then your little active inference scheme becomes the thing that has to learn from experience. But the experience is only limited to being able to prompt the large language model. So that now, it's not going to, you're not going to be able to build tech that allows you to send drones, autonomous drones, into a mine to rescue miners, but you will be able to showcase the technology and the ideas by saying, look, I've got a really efficient way of letting this active inference agent learn from experience by producing the right prompts that query a foundation model that knows everything. So now the action of the active inference agent is to prompt. And before its prompt, it doesn't know how the large language model is going to respond, but it does know it's going to find something. And then you can get into the weeds of the generative model used by your active inference model to then try to evaluate the expected free energy of what to prompt a foundation model. So this would be one way of transferring knowledge from a large language model to a small agent on the laptop, where you're actually showing that this small agent can install in itself what it needs to know by asking the large language model the right kinds of questions. So that would be another way of, if you like, using your expertise and your fondness for large language models and your acknowledgement there must be lots of knowledge there somewhere. It's just how do I, through an experience interaction with a large language model, ask the right questions of the large language model in order to build my world model, and that also for free gives you, if you like, the action, because the action now becomes a prompt. That would be quite remarkable, because if you can train an artificial agent to choose the right prompts, that would be a first. That would be so at the moment, big tech is focused on producing good responses to the prompts, and all the money is to train people to do prompt engineering. There are now courses, university courses on prompt engineering. If you can show that you can actually, through learning by experience, get an artifact to select the right prompts from its perspective, and that is the experience, or the experience is consequent upon the right prompts, that I think would, people would open their eyes and think, oh, that's interesting. How can I generalize that kind of technology? So that would be another way of, if you like, avoiding having to buy a whole a little warehouse of GPUs, and also that's going to be useful. We're talking, active inference is all about small, distributed, intelligent, smart data mining. It's all about structure learning on the edge. It's that's where the real intelligence lies. It's not about just putting all your knowledge into a trillion connection strengths on a universal function approximator. It's much more about the experience that ensues from acting upon the world. So that would be another thing that you might want to think about in terms of showcasing. Just one bit of practical advice. Your presentation was extremely polished, but you need to dumb down a bit in terms of explain to people what is actually being done here. So you need to actually show a simple example of the tasks that you are benchmarking, and you're using the falsification or failure as a methodology. You need to show people simple examples. Just show the prompts and the answers, so people understand concretely what you're actually doing. Otherwise, it's all a little bit it's a little bit magical, and one never quite knows. You can't get a grip on what you've actually been doing. So that was out of context, but that was a bit of feedback about the presentation. It's great to show the results, and it's nice to have this philosophy of falsification and failure as the right way to do your epistemic exploration and optimization, which is, of course, how we all learn. But you need to show what's failed, and just give people a feel for the space in which you're behaving. And I suspect if you did that, people like me and Thomas would be able to understand what you mean by evaluating the expected free energy. To evaluate the expected free energy, let me sort of revert back to academic feedback. The reason that there is puzzlement from people in academia, and certainly active inference, about how on earth you would evaluate the expected free energy given a large language model, is that it is mathematically impossible. Why is it impossible? Well, because the expected free energy is a functional of the agent's beliefs, and specifically the expected information gain part, or the intrinsic motivation that you have been focusing on, is a functional of what of the uncertainty, what the agent does not know. So you can also look at the expected information gain part of the expected free energy as a measure, literally a relative entropy measure of the reduction in uncertainty. But that depends upon the uncertainty of the agent before she asks her question. That means you actually have to have a physical, measurable encoding of the uncertainty in the agent. That's why people in active inference have no interest in large language models, because they don't encode uncertainty. Therefore, they don't have an explicit representation of what they don't know. Therefore, they don't know how to act. They can never prompt because there's no motivation for prompting, because there's no way of measuring the resolution of uncertainty, i.e. the expected information gain. They can never have intrinsically motivated behavior because they don't encode the uncertainty. That's why you need a proper generative model to encode the uncertainty, which is why the view of what can large language models do for active inference is the better view, more than what can active inference do for large language models. Large language models in and of themselves are a lost cause because they do not have the capacity to represent the uncertainty that will be resolved by experience. And so if you move over to active inference as a sort of the central architecture, the right way to do the computer science, then it's just a question, how do I most efficiently resolve my uncertainty? But to do that, you have to have an explicit generative model. And once you've got an explicit generative model, you can then evaluate the expected free energy very, very quickly and simply, depending upon the size of your model and the functional form of the probability distributions that encode the uncertainty. One interesting aspect of that is that your wall number 3, the impasse that you found at number 3, is easily resolved if you move into active inference. And I'll just give you a concrete example to illustrate how you can pass through that particular bottleneck. But you have to really commit to and understand the maths of active inference to do this properly. So the problem that you've contended with is that you now know how to resolve your uncertainty to a certain extent by asking the right questions and exposing yourself to the right experience. But it doesn't seem to work, because if I now eliminate what I once knew and replace it with what I now know next, after I've asked the right question, for example, I get a catastrophic forgetting. And if I change some tuning parameter, then I don't learn. So that problem is resolved in active inference because the connection weights themselves, the contingencies, the rules, the things that you are trying to learn in a machine learning or experience-dependent learning context are themselves represented as probability distributions. So not only does active inference represent the weights, say in a transformer architecture or a UNet, it also represents uncertainty about the connection strengths, which means that when you learn something new, you can update the content or the weights themselves, but you're also updating the uncertainty about it. So there'll be some connection strengths, some rules that are you have some belief about, but they're encoded with high uncertainty. And as you gain more and more experience, you then reduce the uncertainty. And as you reduce the uncertainty, they're now less changeable. So what happens is that you, and just to put this, make it a bit more concrete, in discrete state-space models, the rules or the laws or the connection strengths are encoded in tensors, and these tensors are Dirichlet tensors, and they're equipped with counts. So when you renormalize the column of any tensor, it now plays the role of a probability, so it sums to 1. And then that probability now corresponds to the probabilistic connection strength. If X, then Y, or if hidden state, then the next token or next word, or in a transition tensor, if state 1 t equals this, then the probability of the state at t plus 1 under this action is given now by this normalized Dirichlet counts. So the mechanism of learning, experience dependent learning, is really, really simple when you've actually got an explicit generative model, not just of the latent states, but also the contingencies as encoded in the tensors. And all you do is you just add a count, a Dirichlet count, to the Dirichlet tensors whenever you experience it. And what that basically means is, as you're accumulating experience, you're accumulating not only the most likely thing that's going to happen next, or the most likely thing I'm going to see if I'm in this latent state, but also you're accumulating confidence. And as you accumulate more and more confidence, experience has less effect. So I'll just make that concrete with a simple example. Let's say that I want to learn whether this is a fair or unfair coin. And I start off with sort of one, as people do, a baseline a priori, one Dirichlet count for heads and one Dirichlet count for tails. And I flip it once and I see I've got now heads. I got 2 heads and 1 tail. So I sort of normalize that. I'm sort of 60-30, this is a head bias coin, but I'm pretty unsure about, whether it is. Now I after 100 observations, I now find that I've got 51 and 49 heads and tails. And now I've got a posterior belief, this is probably a 50-50, roughly a 50-50, in fact, it's 51-49. But crucially, I am very confident that this is now a fair coin, because if I now see another head, I'm now just changing the ratio from 52 to 59. Whereas when I was young and naive and impressionable, before my experience, I would have gone from 2 to 1 to 3 to 1. So the ratio of the probabilities is now much more susceptible to experience, because I've encoded the uncertainty about what I believe in things. So what that means is that you can now preclude or avoid the catastrophic forgetting of things which you are confident that you know, and that you're confident you know them because you've experienced them many, many times. Furthermore, the fact that you don't know some other things means that now has an intrinsic motivation to try and put yourself in situations where these contingencies are going to be experienced. So knowing the uncertainty about your connection strengths now allows you to choose those actions that are going to give you the experience to accumulate these Dirichlet counts where you haven't accumulated them, where you're very uncertain about the rules or the games in question. So that would be a first principle Bayes optimal way of experience-dependent learning. But notice it does rest upon encoding explicitly your uncertainty about the rules and the experiences or the causes of your cause-effect structure of your experience in your artificial intelligence. So that, I think that your bottleneck, your sort of block number 3 is very passable, but you're going to have to commit to doing it properly. You won't be able to ever do this with a large language model. You're going to have to do it with an active inference agent. And then your game will be, how can I make this active inference agent really efficient using a large language model? Or how can I make this active inference agent showcase itself by actually acting upon a large language model, getting the knowledge from a large language model in an organized way into a small, efficient active inference agent that will then, you've basically built an artificial prompter, and that would be quite remarkable. If you can do that, I think people will really sit up and listen. But it will, I think, require you to do learning properly And by which I mean you have to really sort of go back to first principles and use active inference. You can't use reinforcement learning because you have to use the intrinsic motivation, not the extrinsic motivation to do this. I've been wishing on, and it's time for me just to show. Yeah, I'm sure you've probably read these papers, but I thought I'd just for completeness show them if I've got them here still. Oh, yes, I have. Where are we? Yes, I have to share my screen. Share the screen. This will only take 1 minute. I'm just doing it for the recording, not for you. All right, so we're nearly finished now. Right, where are we? This is not what we want. What we want is this it? I'm not sure. Perhaps it's this.
Also, Rahul, can I ask you to stop sharing your screen for
Yes,
now?
yes, yes.
Oh, am I not sharing?
Now you are. Now you
Am
are.
I? Yeah. Oh, I have to close that then. All right. So I'm trying to find my buttons at the bottom, which have become obscured. There it is. Yeah, this is the paper that just takes you through that Dirichlet story I just told you. And it takes you into slightly the next part of the story speaks to your important focus on recognizing a change in the context and the new learning and the new kind of epistemic foraging that would be required. So what I've just described to you is if the world is not changing, how do I most efficiently accumulate experience and put that into my generative model in a way that optimally renders me impressionable, or that I have the right kind of plasticity or learnability that is, and also renders certain moves more attractive in terms of the information gain, not about the states, but about the connection weights or the parameters in and of themselves. You can also extend the same idea to the actual model structure, and I'll refer to that right at the end. However, what you're interested in is, okay, that's fine. I've learned about this world. What about when the world changes? That you have to put into your model. You have to have a model, a generative model that allows for a changing context. And as soon as you've got a model that allows for a change in context, that means you can protect everything that you have learned in the first context, because now you're in a new context, and therefore it requires now new learning. So there is no catastrophic forgetting in active inference. All you're saying is that if you want something that is context sensitive, you have to build a generative model or a world model that has the ability to recognize a context.
Right.
Once you recognize the context, there is no catastrophic forgetting, but there's now context sensitivity. And also, you don't have to worry about how do I recognize the context has changed. You've got a model of the different context. So if the evidence for being in the same context, the initial context falls, then that is automatically evidence that the context has changed, and then you acquire data under that. So just having a generative model in which there can be more than one context automatically solves all those problems that you would find in conventional reinforcement learning. This slightly addresses that in the context of something in neurobiology called reversal learning. So people actually play this game with rats. They sort of reward a little rat to do one thing, and then they reverse the contingencies. And then they see, that's called reversal learning. And of course, a large language model wouldn't know what to do because it stopped learning. But the rat can actually now forget about it in the previous context and learn a new context. And that takes a bit of time. It's very inefficient. You and me, we are not like rats. We actually know that the context can change, and we would recognize immediately that the context has changed and immediately flip to a new context. So you get increasing levels of sophistication with the increasing depth of the generative models. So this paper is sort of halfway between that and just talks about the maths and the Dirichlet counts for epistemic foraging and learning, and the changes that we've got a change here, and the different kinds of responses to reversals that you can simulate. But I'm suggesting this because it just takes you through. If you're a computer scientist, you'll understand the maths easily. So within a weekend, you can get on top of this and hopefully start to implement it. And the implementation, again, there are communities out there that are providing Python and Julia, and our MATLAB is supplements that software to build these active inference agents. So I thought that might be a nice place to start, just to solve roadblock number 3. The extension of those ideas about prompting in the right way, asking the right questions, making the right moves, so that whatever happens, you're going to learn something, can also be applied to the actual model itself. So now we're beyond just the connection strengths. We're beyond the tensors. We're now actually, how many tensors are there? How deep is the model, for example? One application of the expected information gain can be to the actual structure in and of itself, as in causal discovery. So this is a recent paper by myself and Thomas and other colleagues. Yes, and these are the kinds of people you need to email to see if they can offer you a job in some stealth startup, which I don't know about. So no, it doesn't tell you where to get it from. If you just Google this, you'll find it on Archive, and it's just the other end of the story. So once the first paper was at the beginning of the story, this is right at the end. It's the highest level application of intrinsic motivation, not be about states, not about parameters, but about the actual structure of the world model in and of itself, which you may find useful in the future. And I've just put this paper up just to reiterate the suggestion that don't worry about scaling up. You don't want big. Big's useless. Big data, large language models, they're incredibly inefficient. They're not explainable, and they violate the fundamental laws or principles of least action. If you want true intelligence and experiential learning, you have to find those scale-free principles and then apply them at each small scale, so that you've now got the right kind of deep structure that you will acquire. And this is just a mathematical illustration of this approach, using these Dirichlet count sort of encodings of contingencies and connection strengths, if you like, in a discrete setting. Again, this one is not for your mathematical education. It's just an example of another way of thinking about scale, which I'm proposing is maybe useful for you if you've only got a laptop at your disposal. And that's it. Yes, I've gone slightly over my 30 minutes. I'm playing Thomas.
No problem at all.
Am I allowed to have some questions now, or like it's not?
I can give you 8 minutes quickly.
8 minutes.
Until 5:30.
So I can do one thing. I can just share the questions I had when Carl was speaking. Like you may answer in text also whenever you get time. So I would just speak very fast the questions I had. The first question I had was considering a hypothetical situation, like if you were to build, means any one of you or all of you combined, uh, and sentient artificial intelligence, where like in terms of robots or uh, like we have seen the humanoid types of things, like we have seen Terminator movies or the much popularized Westworld version. So like how would you be building it? Like what components would you be using it? And like this is the one question. The next question is regarding about active inference. Like there are four fields like that I have in my mind. Like first is LLMs, like this is JPA architecture thing. Then next is reinforcement learning, and the fourth is active inference. So from all these four, this is my intuition or the understanding that I have as of now. Like active inference seems to be most near uh, to have a true artificial intelligence where like a human, most near to human intelligence. So like how means the example I take right now myself with like sending a robot on the Mars or moon to build a colony for humans, like domes, building colonies, building the whole infrastructure where we can produce oxygen, water, everything under the shade and everything, and then humans can be brought there. So for such robots, I think active inference principle based intelligence would be the best. So if you have a difference of opinion on or more things needs to be done, so you can let me know about that.
Let me
Next,
stop. Hang on. I need a cigarette so Thomas can answer two questions. And one thing, um, don't email people like me and Thomas. I'm too old. And I can't
okay.
adopt anybody else. Thomas is too young and too busy. So this is why we have these sessions. This is it. This is the joy of talking about these things. So you absolutely take as much time as you want talking about it. But I do need a cigarette. So Thomas, can you take over and answer those questions, and then I'll come back when I've had a cigarette.
I've got 5 minutes to answer how I build a sentient creature.
Yes. So like when we are building like LLMs also right now, still humans are required to like reinforcement learning with human feedback and like rewarding the systems, then labeling the high quality data. So when we are doing the work as a human, we don't need any other life form. So if we want truly artificial intelligence, then humans needs to be removed from the picture. Means they can themselves carry forward. Like this should be the criteria for that. And apart from that, okay, this is the all. And the last thing was like why my focus was more on the startup side was like the LLMs have been going on for at least 5 years or more. Recently, like the Lee Kuhn has started his own startup like AMI Labs uh, from Paris, I guess, and has raised even 1 billion, even on the seed without any product, without anything. Second is, I think you know more probably. He's from London itself, like David Silver for ineffable AI, like pure RL based active inference sentient life. They also went ahead with 1 billion seed round and without any product, without any product line coming even in 2 to 3 years down the line. So what I feel that the velocity or the that we feel it's going with a great pace. So having a startup or even having at least a frontier research lab team where we are progressing all these things could be a best way to start. And then once we achieve the progress, then we can suddenly shift towards the commercialization of things. So this is the all things in question I have. Like if you feel that the time is up, then you may answer whenever you feel like, even in the text also, email also.
Well, let me try and do my best to answer those. So the last question was about what's the right institutional setup to accelerate this sort of research as best as possible. And I suppose, a trivial answer to that is I don't know. That probably it comes down to a combination of all of these things. And remember, each one will have their own agenda. So if it's in a startup setting or in a company, then clearly the agenda will at some stage be to have a commercial product, and that's a very different agenda to what an academic who wants to understand how the brain works might approach things. I suspect having all of these things at some level is probably the right answer, that actually having lots of different agendas, lots of different approaches, lots of different avenues is probably key. In some ways, I think that also speaks to your first question, which was around how I would go about building or working towards developing a sentient creature of some description. And I think probably the easiest way to answer that question is to look at how nature has done it. And it is having lots of different versions of it that you can select between, doing it in lots of different ways in lots of different environments. It is the process of natural selection, which from an active inference perspective becomes a process of model selection. It becomes having lots of hypotheses about how one might approach it, and having lots of people who are trying out each of these things and seeing which models are the best fit to the world, where that fit is scored by how much they can reduce their free energy. The interesting additional bit on that is that natural selection clearly works on probably someone will criticize me for saying this, but there's a random element to it, that the mutations and the like sort of give you a very rudimentary form of exploration of the possible space of models I could have. And some of the papers that Carl showed you a moment ago focus upon a much more directed way of exploring model spaces that might speed up that sort of process. And in particular, that's using expected free energy as a way of scoring alternative ways I could modify my model to make it better and better at explaining the world around me. So I think that that's a sort of version of a natural selection, that it has a much more directed, these are the ways that I can grow and mutate my model to make it as best as possible. I think your second question was, do we think active inference is the right way of doing this? And yes, essentially. I'm just under 5 minutes there. Carl, did you have anything to add?
Yes, I always have something to add. So yeah, can I just tell you off about that randomness? But it's a really interesting conversation. It's nothing to do with Rahul's questions, which I will briefly rehearse after Thomas's answer. So in theoretical biology, and I'm thinking very much along the lines of people like Stuart Kaufman, there's a notion of selection for selectability. And beyond that, there is higher order selection. So the mechanism of selection is itself subject to Bayesian model selection. So in fact, genetic random mutations are absolutely not random. Sexual reproduction is not at all random. It has itself been selected to find the symmetries which you and I have written about. So you can get out of that by just pointing out this is not random. It's not greedy search. This is highly evolved, highly structured explorations of hypotheses spaces in a very difficult space that doesn't usually have anything apart from an information geometry. So that's a really fascinating area. And it comes to mind simply because this is one example of a scale-free application. It's applying the same principles, basically a free energy minimizing process, i.e. Bayesian model selection, at a scale above the phenotype or the artifact that you're trying to select for. But that process of natural selection is itself selected by an even higher scale. And hence we have sexual reproduction, for example, or different kinds of crossover mutations and the like, which are very carefully crafted to explore in the right kind of way all the different phenotypes that could be engendered. Yeah, just coming to that interesting point about $1 billion being afforded startups with zero productization plans. Universally, all of the people who are on these frontier labs who have received this inflated startup funding are turning away from large language models and towards world models, which is exactly where the active inference community would advise. This is basically natural selection acting in tech. It's a slow process, but eventually they will all be doing active inference. Although this has been recorded, you shouldn't tell anybody else about that. So people like David Silver, who's a colleague at UCL, but particularly people like Jan LeCun, they are famous for saying, no, large language models are not the right way. You need to actually understand and build a generative model. They call it a world model, a term introduced by Jürgen Schmidhuber. But it's basically just a world model. So the fact you brought those things to the table is an interesting, if you like, symptom of the fact that people recognize that large language models are a dead end because they're so inefficient and they violate both the laws of natural intelligence, but also physics, natural sciences, because they transcend the principle of least action. So I would take heart that there is a lot of money around being pushed into world models, and maybe you can get a job with one of these companies. And just quietly tell them, don't say generative models, just say world models, and then be well happy. You listed a few things like reinforcement learning, JEPA, active inference. Reinforcement learning and JEPA are special cases of active inference. The reinforcement learning is when you switch off the intrinsic motivation and you have a very, very simple expected cost, which is usually in one or two number of reward functions. So reinforcement learning is just active inference without intrinsic motivation. JEPA is active inference without the encoding of uncertainty, sometimes articulated in terms of a zero temperature free energy. So the zero temperature basically nullifies, sets the entropy to zero in a free energy function, which means, and the entropy is the thing that holds the uncertainty. It scores the uncertainty. It's what you need to evaluate the expected free energy and the resolution of uncertainty. But because Jan and JEPA enthusiasts are engineers, they're making their life easier, thank you. We'll just ignore that for the moment. It's not actually set to zero. It just means that the uncertainty, it doesn't get into the gradients for the learning. So it could be big or it could be small. It's just fixed. So it's not a function of your of the encoding of the expectation or the modes of your beliefs, so they can work with sort of delta functions. It just makes life much, much easier. The problem is you can't evaluate the intrinsic motivation, so you never know what to do. So then you have to introduce all sorts of heuristics to make these things work, as in reinforcement learning, dropout, mini batching, all sorts of little tricks to avoid the sharp minima that ensue from not encoding the uncertainty properly by eliminating the important role of uncertainty or entropy in an optimization scheme. So the answer to your question is it's always active inference. There's a more principled reason for this. Active inference is not an idea. It's not a good guess or a hypothesis or somebody's bright idea. It is just a natural consequence, a mathematical consequence of the physics of self-organization. So there's a physics backstory to active inference where all the heavy lifting mathematically is done that says it has to be this way, it can be no other way. Your job is just to try and implement it. And that comes to your first question. And I often look at this and say, well, what people actually want. And it's interesting that both of you were sort of focusing on sending drones to Mars or the moon, the dark side of the moon, to build. So I think you're not talking about humanoid robots. There are good reasons why you might want to build humanoid robots in terms of projection and enabling people to anthropomorphize things. And also, factories that have been designed for human workers are going to be much more aptly serviced with a humanoid robot. But in terms of what people actually want, they're going to want very durable, lightweight, efficient drones, either ground or air, or autonomous vehicles, to go where man can't go easily. So what you're talking about is building effectively bright, very intelligent little insects. That's the level I think you should be pitched at practically in the short term, and that takes on, I think, a sort of morbid but sort of important prescience when we think about warfare at the moment. So all research at the moment that is applied in a meaningful way is about drone research in a military context. So that's where I think the money will be ultimately. Either sex industry, games, or war. That's where basically that's where you're going to find the advances. So don't worry about war, because we don't like war. But you can certainly think about sort of autonomous vehicles and drones as a that's where you need this experience dependent learning. So that would not be softer robotics. It would actually be hard robotics. And there's a lot of engineering in realizing these principles of least action, which all involves basically getting your active inference scheme off a GPU and onto a what do they call them? Raspberry Pi or or what is it, Orion? What are these sort of very simple little little boards?
Yes.
That's the game. That's to make it as efficient as possible so you can put it on a drone and make it do what you want it to do.
Thank you. And regarding I think the job point, I think Thomas and I think you also mentioned, like I have not been doing any job. I had left my job months back. I am doing day and night only this on the laptop in my room.
Well, you should start emailing everybody you know to see if they'll give you a job. That's the and anybody you don't know who's clearly invested in this at one level or another.
The last question, like if I start like this as a frontier lab or like the startup for this, like would you be happy to advise, like not on time-based manner or anything, whenever you want, anytime you want, you and Thomas?
I try to minimize my commitments because I'm overcommitted. But what I normally offer, and Thomas will have a different answer, but what I normally offer is you can certainly use my name, but practically what that means is access to these meetings. So they're academic, no disclosure agreements, pure academic exchange for the common good, and it's online. So I don't have to wade through 100 emails. So if you find yourself in that position, you can certainly say that you've been in conversation with me and I will lend you moral support and you can use me as an informal advisor. But practically what that means is using these meetings. And that means you have to get through the chairs to get your slot booked. Thomas may be in a different position. He may be, he's at a stage in life where he has to think about building infrastructures, building institutional capacity to service the academic, intellectual, and possibly clinical hunger that people you currently have.
Right.
Yes,
So, Thomas,
I mean, I'm sort of not in a stable position myself in terms of my academic time. I think I have just under 2 months left of funded academic time at the moment, unless I can find some other way of funding it. So after that time, until I can find something else, I will be working full time as an NHS doctor, which does limit the amount of time I can spare even for meetings of this sort. So I hope that will change with time. But I think if you're arranging to present at this sort of meeting, I'm happy to try, if I am available that day, to attend and give advice in this sort of setting as well. But probably I can't offer anything above that at this point in time. That may change with time, but at the moment, that's the situation I'm in.
Like I'm happy to like have you as like informal advisor also, like not even the formal advisor, whatever you can, whenever you can, completely with your convenience.
Yeah, the other option is to get yourself associated or affiliated with the Active Inference Institute. There is a lot of expertise there. It's broader than what you're looking for in terms of a startup, but at the moment, that's the only international institute that has
Right.
a legal standing. It's a registered legal entity that would be a source of institutional endorsement if you are talking to angel investors and the like. And indeed, this meeting, the chairs organise this meeting under the auspices of the Active Inference Institute.
Active Inference. Right.
Yeah.
That is also a good suggestion. Yes. Like anything from chairs, like nobody from chairs has spoken anything, asked or shared anything. Anything from you.
I can just say, feel free to write us an email, and what we can do is we can get you in touch, for example, with Daniel, who's the president of the Active Inference Institute. We'll be very happy to do that.
Great. And like last thing, like how can I be connected with the like Active Inference Institute? Like in what capacity? Like if I want to do this thing, like how can I do this?
So I think I personally I'm not in a position to tell you that because frankly I'm just a small fish in the Active Inference. But you can talk to Daniel, and I'm pretty sure you can find something that will be useful to you.
Sure. Thank you.
Okay, then with that, it was a fantastic meeting, an extended one. Let's give Rahul one final round of applause.
Thank you so much. Like, I'm indebted to all of you for giving this opportunity. And like, I never thought like when I read about the active inference and I Googled it or searched on ChatGPT, the limitations were shown like it is mathematically hard to scale. So when I heard the word mathematics, I thought, oh my God, now how would I learn it? But uh, like uh, like when I was in school, I had the two very difficult subjects in which I achieved the lowest marks. First was the English. Like I was a Hindi speaker, being from India, Central India. So I didn't know like what do people are talking about, what they have been saying. Second was the mathematics. So I think the first one has been solved. I think I am going to work on the second one now. This might help in understanding all these things in going ahead. Thank you so much again, like expressing my deepest gratitude and the examples and suggestion like the Carl gave about the intelligence, like intelligent prompting, I would be working on. And whenever I am ready with that, I would be requesting for a meet again. Hopefully, we will get to meet and have words again.
Okay. Yeah, feel free to reach out to us anytime.
Okay.
Thank you very much.
Thank you. It was
Thanks.
really pleasure. Really pleasure. Yeah.
Bye-bye.
Have a great day ahead.
Bye-bye.
Meeting you soon. Hope to meet you soon, all of you.